Welcome to my bottle rocket launcher video. Here's my bottle rocket launcher. It has many features which allow for different types of launches. The main part, however, is the release mechanism. As you can see, it's controlled by air pressure. Pulse of air causes the bottle to be released. I use streamlined 1 liter bottles for my rockets. I also use parts of 1 liter bottles to make the tail sections. This one is cut out so that it makes the rocket spin. Tails made this way have many advantages over delicate and dangerous fins. One advantage is that having the same diameter as the rocket, they help guide the rocket out of the launcher. The fins are attached to a nozzle, which screws onto the bottle and is held by the rocket launcher. The nozzle has a jet inside, which controls the rate at which the water can exit the bottle. I have many interchangeable jet sizes. These can be used to alter the thrust and burn time. Okay, let's launch some rockets. First, a measured volume of water is poured into the bottle. Next, the nozzle is screwed onto the bottle. And then the launch collet is removed from the launcher and is attached to the rocket nozzle. This is so that no water is lost in attaching the rocket to the launcher. The launch collet has a check valve in it so that water cannot drip out when it's inverted and installed on the launcher. Now we charge the bottle to whatever pressure we like. Press the fire button. Notice how rockets which are fired vertically or near vertically float back to Earth in a horizontal position. This is an added feature of the rocket tails. Rockets suffer less impact damage and are safer. In the beginning, I made rockets which would come down quite hard and were quite dangerous to own with. These few launches are at fairly low pressure, 30 or 40 pounds per square inch. My launch site is surrounded by green trees, and since the bottle rockets are green, it's very easy to lose the rockets in the trees. Now later we'll go to a soccer field. Now for a slow motion of the rocket launch. This is about 1,000 frames per second. Sometimes you want to measure the maximum altitude that the rocket makes. And for this reason, I've added a bracket for a spinning reel. You attach the fishing line to the rocket, and after the launch, you can measure how much line was taken out. Here we are at the soccer field, where the trees are further away, and we can up the pressure in the rockets. Okay, here goes the first rocket. Notice how nicely the bottles float back down to Earth. Now we'll up the pressure to about 100 pounds per square inch. This rocket has aluminum fins, which does make it more stable in flight. we're going to use a 2-liter bottle with the aluminum fins. This really goes high. It also really comes down fast, as you'll see. Now we're going to add cameras to the rocket. One camera pointing forward and one camera pointing backwards, so we can see what it's like to be in the rocket frame. Okay, now what it looks like in the rocket frame. That all happened pretty fast. Let's see it again, slowed down to half speed. And again in the rocket frame. Well, that ends my rocket launcher video. Thanks for watching.